see another name for this address. We call it BIA or burned in address. Okay, this means that this is a fixed address. We can change it, and this address should be unique in all of the world. Why? Because assume that we are buying 5 network interface card from 5 vendor. When you are using this 5 network interface card in your 5 PCs in your network, if 2 of these PCs are using the same MAC address, they can't communicate to each other. But how we can ensure that the MAC address, the address that we are writing, we are burning into the RAM chipset is, for example, unique. What is the method? You know that, assume that we have 5 or 10 or more than this, the manufacturer about this network interface cards, and all of them does, for example, do not have any communication with each other. How they can ensure that the MAC address that they are using is unique? Okay, this is one important question. We have some mechanism about this, and we can use this mechanism for ensuring the uniqueness of the MAC address. Very good. Until now, we learned that we are talking about the Ethernet LANs, and we are talking about the one of the logical function of the Ethernet LANs, and the name of that function is Ethernet addressing. We will use this Ethernet addressing in the Ethernet framing in this video and in the next video. Okay. After that, we learned that in each network, in each technology, LAN technology or WAN technology, we need address for sending traffic to the destination. Okay. In Ethernet, the address type is MAC address. Okay. Now we are learning about the MAC address, and you know that the MAC address is the physical address, is the address that we are using it for giving traffic to the for example, receiver. Okay. And now we know that the MAC address should be burned by the manufacturer, by the vendor, into the RAM chipset installed in the network interface card, and we can change it. Okay. Now I'm going to talk about the structure and the detail of the MAC address itself. Okay. MAC address has 48 bits. 48 bits. Look at here. This is the MAC address, for example. As you can see, here we have 48 bits. You know that working with binaries, such as the working with binary in the IP address, here again, the working with binary is hard for the for us. We can't use the binary. It's better to converting the binary to another base. For example, about the MAC address, we are using the hexadecimal base. Let me to write here. You know that we can write each 4 bit with 1 hex character. Let me to review this for you. Quad 0, then 001, then for example 0010, then 0011, then 01, okay, 00, then 0101, then 0110, again 0111, after that 1000, then 1001. Okay, after that 1010, then 1011, and then 1100, 1101, 1110, and finally quad 1. Okay, these are all of the combinations that we can have with 4 bits. Okay, and here we can write 1 hexadecimal equivalent. For example, the equivalent of 40 is in hex is 0. This is a hex character, not the decimal character. Then 1, then for example 2, again 3, again for example 4, then 5. Okay, after this 6, then 7, then for example 8, after that 9, and after that the 1010 equivalent in hex with A, then B, after that for example C, then D, and after that E, and finally the F. In hexadecimal we have these 16 characters 0 to 9, okay, and then from the, for example, A to F, A, B, C, D, E, F. Okay, we can convert each 4 bit to hex. It's easier to work with 12 hex characters. You know that because we have 48 bit, this is the 48 bit, let me to write here. Because of that, you can convert these 48 bits to only 12 hex characters. Why? Because each 4-bit can be converted to for example, 1 hex character. For example, let me to show you. Look at here. Here, this is the MAC address of our network interface card, and this MAC address is burned or was burned into this chipset. Now I'm going to convert this 48 bits to 12 hex, okay, hex characters. Look at here, 0101, 0101 equivalent to the 5. Then 1100, 1100 equivalent to the C. Then 1000, this is 8. Quad 0, 0, 001, 1, 1101, look at here, 1101 equivalent to D. 1110E. Then 0111, 7. After that, for example, quad 1 F, 1011B, 01106, and then 00113, for example. This is the MAC address. Now we have only 12 hex characters, and it's easier for us for working with this address in compare of the 48 bits, okay? Because of that, the OS, the operating system, can convert the MAC address from binary to hex for us, and from the, for example, hex to binary for the hardware. Very good. Now we have another notation about the MAC address. When you are writing the MAC address, or when you are working with MAC address in different vendors, maybe you encounter with different type of notation. For example, in Cisco, the Cisco is adding 1 dot between each 4 hex characters. For example, the Cisco added a dot between these 4 characters, then again 4 character, and finally here we have another, for example, dot. Look at here, this MAC address in Cisco devices in most cases is written with this notation 5C18.1DE7.FB63 dot. Here we don't have that, but here we have 2 dot. This is the notation that we are using it in Cisco, for example, presentation, and this is the dotted triplet notation. If you hear about the dotted triplet notation, means you are using the triplet part or triple part, and between each part we have a dot. But in Microsoft or in some other vendors, maybe you encounter that the characters is divided by 1 hyphen, as you can see here, between each 2 character. It's not important for us. Both of them are same, and maybe you sometimes use with this method of the dividing, or with this method. Both of them are same. It's not important. This is only a notation. Okay, now we learned about the MAC address structure. The MAC address has 48 bits, and in most cases we are using the MAC address. We are working with MAC address in hex with 12 character, okay? And we know that we can divide the MAC address with different types, with different formats. Now, let me to talk about the detail of the structure of the MAC address. You know that we have one consideration now. That consideration is that how we can use a MAC address without worrying about the uniqueness of the MAC address. You know that we are worried about the duplication of the MAC address in our networks, because when you are working in Ethernet network, if 2 network interface cards are using the same MAC address, okay, you can't give the traffic to one of them because both of them are using the same MAC address. Because of that, we should know that we have one specific structure for avoiding the duplication of the MAC address in the networks. Because of that, for learning this, let me to talk about 2 parts of the MAC address. This is the generic form of the MAC address. Look at here. As you can see here, we have 12x. X is a hex character, means a number between 0 to F, or a character between 0 to F. Okay, because of that, here we have 12 hex character. Each hex character can be between 0 to F. And now, as you can see here, we can divide these 12 characters, 12 hex characters, to 2 parts. The first 6 characters, okay, is the OUI, or organizationally unique identifier. You will learn about it, but let me to say that this is a unique part of the MAC address, okay? I will talk about that. And after that, we have the next part. The next part's name is vendor assigned address, okay? Until now, we learned about that in one MAC address, we have two parts, OUI and vendor assign VAA or vendor assign address. OUI has 24 bits or 6 hex characters. Let me to write here. You know that here we have 6 hex characters. 6 hex characters means the, for example, 6 multiply 4 binary bits or binary, for example, digit. Look at here, this is equal to 24 bits. Again, about the vendor assign address, we have the same formula. Because of that, finally we have 48 bits. And let me to say that we are using the OUI for uniqueness of a MAC address with the method that I will talk about that. And also we are using OUI for uniqueness of MAC address in all of the world. This is universal uniqueness. But we are using the vendor assign address for uniqueness of one MAC address inside of the products of the one vendor. Okay, let me to talk about that. You will better understand it after learning about the OUI function or organizationally unique identifier function. Let me talk about the OUI. Look at here. When you are creating a network interface card or a device that needs the MAC address, okay, for example, Cisco creates with some interfaces that interfaces need the MAC address, or some other vendors creating the Ethernet interface, Ethernet port, and that ports needs the for example, MAC address. They should receive from the IEEE one unique 24 bits. We call it OUI. For example, this is only one example. This is not, maybe this is not real in all of the parts. Look at here, the Xerox company, one of the one of the first company in the network, now is going to create some network interface card or some devices that they need the MAC address. Okay, the Xerox company, after for example, giving from the IEEE, the OUI should create its MAC address. Let me to show you. For example, this is the OUI of the unique OUI of the Xerox. This is the proprietary for the Xerox, and the IEEE does not give this OUI to another company. Assume that this is the OUI of the Xerox. Also, as you can see, Cisco has this OUI, and also the AMD has this OUI. As you can see, these OUIs are different. Because of that, we call it organizationally unique identifier. Each organization can take one OUI, or in some cases, when the company creates multiple type of devices, the company can give multiple OUIs. Okay, but when a company takes OUI from the IEEE, it should use that OUI in the first 24 bits or in the first 6 characters of all of its products. As you can see, now Xerox is using this quad 001 6 hex characters in the start of the MAC address of all of its products. As you can see, also Cisco, also AMD are doing with the same function. And after that, they can unique their products and for example, between each other with the vendor assign address. Assume that this is the MAC address of the equipment one of the Xerox products. The organizational identifier of all of the products are quad 001, but the vendor assign address are different between these products. This means that with organizationally unique identifier, we can unique or we can ensure from the uniqueness of these products with the products of other company. Okay, but with the vendor assign address, we can unique our products inside of the other products of our company. Okay, this is the function of the OUI and vendor assign address. When you are creating